Hey everyone, welcome back to the channel. Today we're diving into a topic that has been on the minds of many in the crypto space, Bitcoin. We all know its price swings can be wild, a real roller coaster. But there's another, more futuristic threat looming on the horizon that could shake the very foundations of not just Bitcoin, but all of modern cryptography. I'm talking about quantum computing. Is this a real danger or just science fiction hype? Let's break it down. First, let's talk about what makes Bitcoin so secure right now. At its core, Bitcoin relies on something called cryptography. Think of it as a set of incredibly complex mathematical puzzles. And when you send Bitcoin, your transaction is signed with a private key, which is like your secret password. This signature is then verified by the network using your public key, which everyone can see. The magic is that it's practically impossible to figure out your secret private key just by looking at your public key. This is thanks to a mathematical problem called the elliptic curve digital signature algorithm, or ECDSA for short. For today's computers, even the most powerful supercomputers in the world, trying to crack this is like trying to find a specific grain of sand on all the beaches on Earth. It would take them billions of years. This is what keeps your Bitcoin safe and ensures that only you can spend your funds. It's the digital lock that protects your digital gold. So, where does quantum computing fit into this picture? Well, quantum computers aren't just faster versions of the computers we use every day. They operate on entirely different principles, using the bizarre laws of quantum mechanics. Instead of bits, which are either a 0 or a 1, they use qubits. A qubit can be a 0, a 1, or both at the same time, thanks to a property called superposition. This, combined with another quantum phenomenon called entanglement, allows them to perform certain types of calculations at speeds that are unimaginable for classical computers. And here's the crucial part. One of the things quantum computers are predicted to be exceptionally good at is solving the exact kind of mathematical problems that protect Bitcoin. An algorithm called Shor's algorithm, designed specifically for a quantum computer, could theoretically break ECDSA. If a powerful enough quantum computer running Shor's algorithm existed, it could take your public key, which is visible on the blockchain, and use it to calculate your private key. Once someone has your private key, they have complete control over your Bitcoin. They could spend your funds without you even knowing until it's too late. This wouldn't just affect one person. It could be used to target any address on the network, especially older, high-value ones. This is the quantum threat in a nutshell. It's the ultimate skeleton key that could unlock every digital safe. Now, before you rush to sell all your crypto, let's inject a healthy dose of reality. The key phrase here is a powerful enough quantum computer. We're not there yet, not even close. The quantum computers that exist today are small, experimental, and highly prone to errors. They have a handful of qubits, and these qubits are very fragile. They need to be kept in extremely cold, controlled environments to function. To break Bitcoin's encryption, it's estimated you would need a quantum computer with thousands, if not millions, of stable, high-quality qubits. Experts are divided on the timeline. Some optimists say we could see a cryptographically relevant quantum computer in the next 10 to 15 years. More conservative estimates place it several decades away, or even further. Building a machine of that scale is a monumental engineering and scientific challenge, far beyond our current capabilities. So the immediate threat is essentially zero. Your Bitcoin is safe today, tomorrow, and likely for the next several years. But what about the long term? The crypto community isn't just sitting around waiting for the quantum apocalypse. Developers and cryptographers are already hard at work developing what's called quantum-resistant or post-quantum cryptography. These are new types of encryption algorithms designed to be secure against attacks from both classical and quantum computers. They are based on different mathematical problems that are believed to be hard for even quantum computers to solve. The race is on to develop, test, and standardize these new cryptographic methods. The U.S. National Institute of Standards and Technology, or NIST, has been running a multi-year competition to select the best quantum-resistant algorithms for future use. The goal is to have these new standards ready long before a threatening quantum computer becomes a reality. So, how would Bitcoin upgrade to become? Ever wondered if the impenetrable fortress of Bitcoin could one day be brought down? The key to that question might lie in the mind-bending world of quantum computing. So, is Bitcoin's doomsday on the horizon? Let's break it down. First, a quick refresher. Bitcoin's security relies on something called cryptography. Specifically, it uses two main cryptographic tools, hashing and digital signatures. The hashing part, which is used for mining, is pretty safe. Even a powerful quantum computer wouldn't really speed up the process of finding the next block. So the mining process is relatively quantum resistant. Phew, one down. But the real concern is with digital signatures. This is how you prove you own your Bitcoin. It's based on a system of a private key and a public key. Your public key is like your bank account number. You can share it freely. Your private key is like your PIN. It's secret, and it's what you use to sign transactions and spend your coins. Here's the problem. A sufficiently powerful quantum computer, using an algorithm called Shor's algorithm, could theoretically figure out your private key just by looking at your public key. If that happens, an attacker could forge your signature and spend your Bitcoin without your permission. It's like someone guessing your PIN just by knowing your account number. Scary, right? But before you rush to sell all your crypto, let's put this into perspective. First, we don't have a quantum computer powerful enough to do this yet. Experts believe we're still years, maybe even decades away from building a machine capable of breaking Bitcoin's encryption. We're talking about a machine with millions of stable qubits, and right now, the most advanced ones have just a few hundred. Second, the Bitcoin community is already working on solutions. The plan is to switch to quantum-resistant algorithms. These are new types of encryption that are designed to be secure against both classical and quantum computers. This switch would be a major upgrade, likely done through a soft fork, ensuring the network remains secure long before quantum computers become a real threat. So, what's the verdict? Is quantum computing a threat to Bitcoin? Yes, theoretically. But is it an immediate, world-ending crisis? Absolutely not. The threat is known, it's distant, and the crypto world is already preparing for it. It's a classic cat-and-mouse game of technology, and for now, the defenders of Bitcoin are well ahead of the curve. It's more of an exciting evolution than an impending apocalypse. Thanks for watching. If you found this explanation helpful, don't forget to like this video and subscribe for more deep dives into the world of tech and crypto. See you in the next one.